Okay, Year 12, we're going to have a look at this geological map which you were set for homework, and hopefully you should be able to build up the sequence of events on here together and look at the application of principles of geological mapping and structural analysis to make sense of what's gone on. I won't do the cross-section for you. The cross-section line was on the map. I hope that you should be able to do that for yourself, but we'll go through and see what you make of it. Okay, so we start off looking at the key to look at what rocks we have got, and you can put a dividing line along there, and you've got sediments below that, and then you've got igneous rocks above. So just bear that in mind, because those will, the rock classes will affect the outcrop pattern on the map. The next job we've got to do is decide on whether this is a flat landscape or whether there's topographic expression, whether they're hills or valleys. And the way we do that is look at the outcrop pattern for gently dipping sedimentary strata. And we've got some of those on the map here. Ignore this stuff here because it's dipping quite a lot. Look at the limestone, that's dipping to 10 degrees to the northeast. That's nice and gently dipping. Now look at the outcrop profile of that limestone, and if we trace it around the map, here we go. Ooh. There we go. So that is not a straight line. I think you'd agree. And the reason for that is that we've got a hill, we've got a valley, we've got a hill. So clearly there is topographic expression on this map, and that's emphasised by the fact that you've got flat-lying rocks, this conglomerate expressed here and here, and those are clearly on the top of hills. Otherwise you would have conglomerate over the entire map. Clearly the conglomerate's deposited and then eroded off the lower sections of the map. So that's very helpful. We know that there are hills and valleys. We now need to look at the structures, and we've got quite a nice set of structures here. We've got an open symmetrical synform. Look at the dip arrows. 45 degrees on the southeast and northwest limbs. The axis of the syncline is therefore trending towards the northeast, and it has no plunge on that axis. And the way you can tell that is by looking at the separation of the geological boundaries on either side of the axis. Notice that they are parallel to the axis itself, so the axis is going through the centre there. So it's not a plunging syncline, it's a symmetrical open syncline. We now have some faults on here. There's a fault there. Clearly the sides of the limbs of the syncline are offset, and the same that side. We've got another fault here because you've got a fault offset there as well. So we have faults trending northwest, southeast, and those faults have been exploited by microgranite dikes. You can tell they're dikes because they are straight. A vertical feature will go straight across the map. Doesn't matter what the topography is like. You can also see that the faults cross-cut the fold, and that will be important as we come to things later on. Now, what else have we got structurally on this map? We've got the limestone dipping very gently at 10 degrees towards the northeast. We have flat-lying conglomerate at the top there, a flat-lying conglomerate there. And that therefore means that the red line that I've drawn here is an unconformity, because we've got a difference in dip between those limestones and the ones underneath. And furthermore, we have another unconformity here, because there's a difference in dip between the limestone and the conglomerate on top. So we've got two unconformities, and both are demonstrated by the fact that they cut the geological boundaries below, in the case of the limestone, and this one because of the difference in dip, and also notice how narrow the spacing is between the conglomerate and the base of the limestone there compared to that. Also note, I'm going to change the colour here, if we look at this igneous intrusion here, it is clearly a sill. It's a conformable hypabyssal intrusion. Forget the squiggle at the end there. It is following the same outcrop pattern as the base of the limestone. Therefore, it is dipping at the same amount as the limestone, 10 degrees towards the northeast. So now we can start to get a sequence of things happening. The The unconformity, this unconformity is clearly later than the fold. The faults are also later than the fold. The fold is therefore the earliest feature. So deposition of the sediments, the mudstone followed by the sandstone followed by the shale with the newest rocks in the core of the syncline, as you would expect. They were then uplifted, folded and eroded, and then you have to look at what happens next. So the fold is cut by these faults, but the faults are overlain by the unconformity. So clearly the faults happen first, they cut through, and then because they have microgranite dikes intruded along them, this intrusion must have happened at that time for the microgranite to penetrate. There was then further erosion and deposition of the limestone above this unconformity here. The limestone would have been deposited originally horizontally. The sill would have been intruded conformably within the limestone, and then all of that block with the stuff underneath would have been tilted at 10 degrees towards the northeast. There would then have been following further erosion, and then deposition of the flat-lying conglomerate is the last episode in the history of this geological map, apart from the fact that you then have uplift and then further erosion to cause the hills and the valleys. I hope that makes sense for you. I'll probably post another map on here and walk you through it, even, and then we will move on to some other geological topics. There will be work to submit in due course, but I'll do that through Insight, and I hope you understood what I have said. If there's any problems, obviously drop me an email and I'll try and sort those out. Happy map reading.